Hey man, welcome back to Man Time. Today's episode, part 2 of the Stihl MS440 blown up chainsaw rebuild. It's already broken down this far, and I've got some surprises in today's video I want to show you, and we're going to get that new cylinder on here, see how it fits, and then start taking this apart so we can split it and put in some new parts. Welcome to Man Time. Alright, so this is where we're at in our 440 blown up chainsaw rebuild, and I've got to get the clutch off of here, I've got to get the flywheel off of there, we're going to do all that stuff, but I was messing around with it, and yeah, crank. This is the first blown up chainsaw that I've got with a bad crank, where the crankshaft actually goes up and down in line with the crankshaft. That's no good. I mean, it's going to be like timing it. I can probably get away with timing it like that, just because it's a minuscule amount, maybe maybe 10,000ths of an inch, something like that. So, I mean, timing it, it's going to be like half a degree off. But I can still get the stroke and everything and lay out my port timing. The majority of the stuff I'm going to be doing in this video, taking it all the way completely down, taking the gas tank and handle off, and getting that new jug on there, new piston, showing you port timing, and then hitting the piston and cylinder, you know, with a Dremel tool or whatever kind of rotary deburr tool you got, and then getting our timing set. I did have to order a new set of bearings and a crankshaft. That stuff I got from Dukes. Again, I'm not sponsored by anybody, but I've always had good lucks with Dukes on a lot of my Stihl stuff, so I just went with them. All right, let's get this on the bench, get this clutch flywheel off of there, and then get some timing numbers on it. I could actually time it just the way that it sits, right? So if you're going to time it, you don't have to pull that stuff off, but yeah, let's just stick that new cylinder on here, time it, and see where we're at before we do anything further. Oh, it's broken. Look at there. That. Oh man, I hope you can see that. Look inside of there. Can you guys see the bearing that the rod rides on is completely broken? Yeah, so right down in here, yeah, that's supposed to be one piece, and I'm seeing at least 3 pieces down in there. Huh. Interesting. Alright, so there you go. Another reason, you know, if this is something you're looking at doing full time, you may want to think about parts plus labor again, because the further you get in here, the worse and worse it gets, right? It's really a losing battle. This type of repair is more for the owner of the saw, or if you just want to basically give the saw away for nothing, you know, to somebody like me that can fix it. You know, that's you know, somebody that is going to take the time to fix it right, take care of it, stuff like that. There again, if you're sitting on a saw like this, actually, matter of fact, if you're sitting on a saw like this, contact me in my About section on this YouTube page. If you want to shoot me an email, say you got a blown up saw, you know, 60 plus cc Stihl or Husqvarna, I'll take it off your hands for you, make a video on it, fix it up the way it should be fixed up. I haven't sold any saws, so I'm not in the business of buying, selling, well, buying maybe, but selling no. So anyways, we're going to get the timing wheel hooked up. I'm just going to hook it up on the clutch side here, and we'll get that new jug piston on there. You want to make sure to time it with the gear that's going on there. One problem I'm going to have is testing the squish, because the squish is going to be forcing the piston down onto the rod, which is slightly unsupported. So I'm not going to get really a great squish measurement, but as far as like the timing numbers and stuff like that, we should get pretty close. Yeah, should get pretty close. The only problem with the saw in the box is, you know, I don't know what screws go with what, so I'm kind of trying to figure that out as I go, but we can get a pretty good idea here of top dead center, you know, without having the stuff on there. So somewhere's around here, and this is going to line up, you know, somewhere over here. So, always keep a nice little piece of baling wire around. Alright, I'm going to tighten this up and get that jug piston on here. See if I can find which screws are supposed to hold down the jug. So the way that I do this is just to get the piston on there, wrist pin through, and then slide the cylinder over. And it's easier on these Stihls to get the bolts started from the back, you know, maybe even from the front. Let's just try with all 4 of them started, huh? I think these are them. I mean, it's the only 4 long ones. Typically the longest ones are designated for the jug, so we will hope that that is the case. Don't lose that. That keeps your carb boot open. Also, don't forget to put it back on there. I'm just going to get this boot out of my way while I'm in here. Don't want to use anything sharp as you're pushing it out of there either. But a whole lot easier to get this down and get it seated onto the crankcase there without this on there, and we can inspect it. Also, Stihl branding on it, no cuts, holes, cracks, and it's still nice and pliable. That's a good thing. Okay, let's get this cylinder cranked down here. Got the jug on there. Now we are going to time this without a base gasket. Man, I would like to get a squish on there. Yeah, I think I'm going to. So I'm going to try to get some squish numbers off of this thing. You want to take squish in a couple different spots, kind of all around the cylinder. And there we go. So I've already done that several times around there. That was like the 5th spot. So you want to check at the thinnest point. Oh man, 22 thousandths. Yeah, 22 thousandths. So boom, right out of the gate, 22 thousandths. So we're perfect. We're moving on, and we're loving life at 22 thousandths. Make sure you take notes of all your repair information. So this is going to be Stihl MS440 with the Meteor piston and jug, and the squish without the base gasket is 0.022 or 22 thousandths. Beautiful. Perfect. Now again, that's actually going to be a little bit lower than what that reading is, right? Because the crank bearing being broken on the crank, the piston is sitting down further than what it normally is. So, yeah. Okay, let's get to top dead center, which, again, we can see right through here. Right there is top dead center. I'm going to lock it in right there, and then just go back and verify with the piston stop. Alright, we are up at 46. Let's come back around. to 30. So we're moving to, let's try 38. And 38. Yeah. Pretty close there. 37 and a half. 37. 37 and a bit. 37 and a bit. Okay, perfect. Perfect top dead center. That's why you always want to check with a piston stop. Nice plastic one. Nothing wrong with that. Okay, let's find our flashlight here. There it is. God, these black ones. Don't ever get the black stream lights like that if you can avoid it. And change your batteries out often, even if the flashlight isn't dead. Maybe set an alarm on your phone, like once a year. I've destroyed several of these, but just this back half of it here, from not changing the battery out, the batteries end up, breaking down before they actually go dead. So, all right, exhaust's opened. And this one, the light's kind of streaming out. We'll just kind of look right in here. So I've got 76, 77. Let's double check. Coming back in. Yeah, right about there. We are 77. 77. So 77. Alright, exhaust. Timing at 77 degrees, which is going to equal 154. 154 degrees duration. Alright, 154. That's not horrible, but it's not great either. And 154 for a 50cc or a 50 millimeter piston. And I think the CCs on this are somewhere around 7. They may even be 70. I think they're like 68 to 70, like a 268 basically. No, it's gonna be the same as a 372, 50 millimeter by 36 stroke. Yeah, 372. So 72. All right, right here is where our transfers are opening. And those are opening at 57. So 57, 67, 77. That's nice. 20 degrees of blowdown. Exhaust. All right. Transfers at 57 degrees equals 20 degrees of blowdown. Man, that's nice. If I liked 154, I'd be real happy there. But I don't like 154, so this is going to increase if I raise the exhaust. But that should be fine. If it ends up at like 22 degrees, I'm still happy there. I mean, right out of the box, Meteor's looking really, really nice. Alright, intake. Let's check that out. Alright, opens. Now this one actually opens on either side of the piston before it does in the middle. Yeah. So right there is where it opens at 75, right on the dot. 75. Equals to 150 duration. Now I want, so I'm going to be shooting for somewheres around exhaust to equal let's just go to 160. 160 is good, 160 is happy, 160 is peppy, and it's 72 cc's. I mean, the same recipe we use for a 372 is probably going to just transfer beautifully. So to get to 160, exhaust work is going to equal to, so we need 6 degrees, so we need to remove 3 degrees from the exhaust roof. So 3 degrees, then my blowdown is going to be 23. Blowdown is going to then equal 23. And intake, want somewhere around 150. I'm at 150 already. 150. I don't want to go any higher than like 158. So, let's just shoot for like 156 to 158. And that's going to be roughly 3 to 4 degrees. 3 to 4 off intake floor. Alright, so how do you determine how much 1 degree is? So what I like to do is like put the piston somewhere in the middle here, and that's going to be somewhere between 180 and 0, so let's just go to 90 and make a little mark. And then we'll go to 80 and make another mark. And then we'll measure between those two to get the number of, or the distance per degree. Distance per degree, that's what we're after. Alright, so I've got my 2 marks on there. I mean, just barely visible. Just put a couple little scratches. Sometimes I'll use blue Dykem or something to get a really good measurement there. So 0.112. 0.112, or right around 10 thousandths per degree. So you do 10 degrees. 10 degrees equals 0.112 divided by 10 equals 0.011. No, that's not right. Yeah, 11. So it's 11 thousandths per degree. Okay, let's get the Dykem. I've got my port timing numbers laid out in here. You can see I put some blue Dykem in there, maybe not see too well. And my video on, I think I redid a 360, basically every other video that I make on chainsaws is like detailed, like how to lay out your port work. Basically, you lay a mark in there with your calipers and then come down. In this case, it's 33 thousandths to get 3 degrees, which increases the duration, double that, 6 degrees. If I do that in both intake and exhaust, it lands me right around 160, 160. But the most important part is the plating, right? So I'm just going to come in here and start hogging out the bottom of these transfers to get that sharp lip off of there. Basically all I'm going to do there. And it's nice. I already got my diamond burr set up for chamfering. Probably grab some safety glasses and start this whole thing over. Basically what I do is just lay out blue Dykem in there on the floor of the intake, roof of the exhaust, and with calipers measure, in this case, 33 thousandths difference. And sometimes what I'm going to do is just come up to that line in the center and then blend it toward the edges. And that's pretty much what I'm going to do here. Symmetrical intake, very nice. So that's sending the charge directly through the center. Slightly offset exhaust, so I may widen it a little bit toward this side here. Definitely going to do that. But the most important part is right here, this lip and this plating. So I'm going to come in there, hit that dry and hit it hard, and we'll see if it holds up. Yeah. So right in there, I just hit the bottom of that that transfer port and just really banking it off of there to see if it's going to start chipping. It did not start chipping. It did not start chipping. So we're good to go. So that was dry. You want to use some lube, and I've got some ATF right here. I'll just dip that in the ATF and then start grinding on this. Of course, with safety gear, glasses, and whatnot, you got chips of aluminum going to be flying right at your face. Alright, one of the last things that I do before calling a cylinder done is go in here with some sandpaper and just all over inside the ports, dig your fingers in there where you can feel those ports, get inside, you know, especially intake and exhaust, where those rings are going to be hammering up and down against there. But transfers like everything, right? And up and down, back and forth, just a whole bunch. So I'm almost done with this one, and you can see here, you just basically take and blend down, you know, where you were porting, but you can see there, nice straight shot into the bottom of the transfers. The floor of the intake there, went around with a diamond burr tool. There's a little nick there, but that was just with the diamond burr, just superficial, again with the sandpaper, you know, cylinder's never going to notice. And then exhaust port there, and just blended it back, you know, to a flat, straight shot. Now, one thing you don't want to overlook is the piston, right? A lot of people are going to dismiss the piston, but especially with these closed port cylinders where the piston is one of your ports, right, the air is flowing through these windows and then in and up to the top of the cylinder. But I take sandpaper, go all around this, and I've ported in these windows right here. You can see some fresh grind marks there, just opened up everything. Again, just trying to make it symmetrical, a little bit bigger, a little bit more robust, and then you can see all these edges around everything, and the chamfer on the top, just sanded down everything, and that way you know everything is gonna mate and break in smooth for you, or you hope so anyway. So the last thing I'm gonna do is just wipe out the cylinder with a paper towel and making sure everything is nice and neat and clean. There is a few spots in here, like on these transfers, where I did experience just a touch of the plating chipping, but luckily enough not on the floor of the intake or the roof of the exhaust. Right there is the biggest chip that I had, and the sanding hopefully will have fixed that up, but yeah, none of the spots that mattered too much, or the spots that did matter didn't have any chipping. So you know, flush it out with your garden hose or in the kitchen sink and soapy water, and just get all of the chips, dust, and then the sandpaper, you know, any particulate that might have gotten in there. And then same thing with the piston. Wash it out good, blow it out with air, and then wipe it all down with a nice clean paper towel, and should be good to go. Well, next steps in this process is going to be disassembling the crankcase, getting the tank off of there. You want to make sure to take like pictures of everything so you can make sure that it's going back together correctly. But all the things that are basically connecting this part to the metal crankcase, all these bolts and stuff have to come out. Now, one thing, if you're thinking about porting and doing that as your job, a lot of setbacks there, because all of the time that I took in porting this cylinder, that is what separates a good port job from a bad port job, essentially. The amount of time you spend with it and the amount of detail and stuff like that. Now, as an industrial engineer, that's bad. we like a stable process, right? We like a consistent cycle time. So when I put something in a lathe that's a CNC, I know exactly how long that part is going to take to come out of that lathe, right? And then you can plan your processes around that. If I got somebody on a manual lathe and I give them both the same job to two different guys, I'm going to get one with a time here and one with a time here, and now it's an out of control process. That's, you know, what we call it. So if you're trying to do this professionally, there's things that you can do, like when you're fabricating motorcycle frames or something like that with a what's called a jig or a fixture, right? So if you could make some sort of jig or fixture that you stick in the cylinder, and you know that cylinder is going to come to you the same every time, and you can then just stick a jig in there and then lay out your port work to whatever desired numbers you want. But the problem is you got customers that want chainsaw to run differently. You know, the port timing defines how the machine runs, essentially. So, you know, depending on what the customer wants, that jig isn't going to work for every single customer out there. It's just a mess. You know, Donnie Walker, I feel for you. He's one of the premier guys doing this, and I think he just kind of says, this is my formula, you get what I give you, you know, type of thing. You know, that's kind of the way to do it. If you can approach it like that, and you got customers that will accept what you're willing to give them, that's, you know, one way to do it. But this will always remain a hobby for me for the foreseeable future, because the amount that I would charge to go through all this wouldn't be worth it to someone, you know, who has a broken, busted chainsaw. It'd probably be less expensive to just go buy a new one, and that's why a lot of the shops won't work on them, and especially to this extent where it needs a new crank, right? A lot of the shops just won't touch it. So anyways, I'm going to see what I can do here to maybe get this gas tank off of there, and then start splitting the case. Again, I am awaiting that crank, and I also ordered a set of bearings from Duke's with another set of seals, because one set of seals just isn't enough in my experience. So anyways, I'm going to try to get this a little bit further apart, and we'll kind of go from there and see what happens. So for getting the tank off of the crankcase, I'm seeing they've got these little kind of stoppers in here, and the best way to get these off of here is just from two sides, pry it up, pry it out, and then you've got a nice dirty, you know, chunk of plastic there. That gets you access right down into the screws that are going from the case into the tank. So there's two on this side. There's also a vent line right here. I popped that off of the crank side, pulled my wires through. You've also got another in-between piece here with this anti-vibe mount. Now this anti-vibe system, you know, they're still using rubber on this saw, but the rubber is, you know, a lot of times I actually kind of prefer the rubber. It's really nice and stiff, like on the 272. Now right here you've got a piece of rubber that just looks like maybe a limiter, right in between here and here. And then you've got another one here, so you got two in the front, you got one here, and then one up here. It looks like those four are kind of the only four you're going to need to get out. Alright, we've got it all blown off here. The next thing we're going to do is attempt to get the flywheel off. Now Stihl has a really nice puller that'll actually thread into the flywheel to get it off of there. And I think I've got one, I can't find it, so we're going to try to figure out a different way, you know, to get this off of there. But it's just, looks like a flange nut that comes right off of there. And since I don't need this crank anyway, normally I'm pretty concerned about the crank and the threads. Not this time around. This crank is toast. So this one is righty loosey. And what you can do here is get something like a chunk of metal. Thought I had something laying around here. Here we go. Like this old vice jaw. and set it right against the crank and the case. There we go. Get a good look at your clutch here. Now, to inspect your clutch, basically what you're looking for is these feet to pull away without any spring tension. This one looks fine. I'm going to blow that off with brake clean. What do we got under here? Got a little plate and then a bunch of garbage. Our worm gear with a little bushing that goes inside of that. Try to keep those two pieces together. Blow that off and then blow all this out. Now for this, since I'm not too worried about it, what I'm going to try to do is try the hammer method, where basically you have a rod and you're kind of holding on to this and then this at the same time and giving that a good whack, and we'll see if that doesn't pull it off of there. My success rate in getting flywheels off like this is I'm like 0 for 10, so I've pretty much quit trying to do it. But one thing you can do also by looking at the clutch here after you get it cleaned off is the blue. You know, the bluing on here, that's going to give you an indication how hard the saw was run also. So you can see some bluing, you know, on all these clutch pads essentially. So another indication the guy running this, you know, was using it hard like it's supposed to be used, right? It's a tool. But as a, you know, total productive maintenance professional, this isn't what I would call keeping your chainsaw in a maintainable state. And you know what I mean there is in the that's going to be too big. Where's that other one? In the book, you know, in the manual, an engineer or team of engineers in there had put a maintenance schedule, right? So every, you know, 10 hours clean your air filter, for instance. Every 15 hours do this. Every 20 hours do that. That is how you maintain your equipment to the factory standard. Oh, that actually worked. Oh man, well, there's firsts for everything still. I'm not too old to still have firsts. That's good to know. Man, us Gen Xers, we give the millennials crap, don't we? Like, get a real job, you know, YouTubing videos, doing little dances and stuff. It's like, get a real job, you know. But, I mean, some of these millennials, they make so much money doing crap like that. It's just amazing to us. We can't quite figure it out, like me making these videos. It's like I'm, you know, making very handy videos. You know, why aren't I one of these kids that makes millions of dollars on some of these videos? Hell, I can't even get 1,000 views on videos like this that are, in my opinion, extremely helpful, you know? Anyways, if you feel bad for me, and other Gen Xers like me, you can contribute through something called a Super Chat, where you donate some money to my channel, and help this Gen Xer learn a hard lesson about making videos that are never going to be anything like what a millennial's video will be. Alright, man, we have got this chainsaw back to a maintainable state. Man, the enjoyment and reward that you get from cleaning something like this out that was just caked with dirt, grease, grime. It's like 2 screws there, 1 screw there, a couple plastic pieces pop out, spray it out with brake clean, blow it out with air. Same over here. I would say this is back to what I would consider a maintainable state, or pretty close to it anyway. I mean, when you're working with something this old and a tool that gets used in the conditions that this gets used in, you know, you aren't shooting for perfection. You can't. There's what I like to call a breaking point, or break-even point, right? And for me, this is fun. This is enjoyable. This is a hobby, right? But there's only so far I'm willing to go for a hobby, right? It's a garden tool. It's just a tool that you use in the woods and around the house to cut down trees and cut firewood. So, you know, I'm only going to go so far with it, but I'm going to take it as far as I can possibly go without stepping over that breaking point, which is, you know, I need this to be a working tool at some point, so you got to know when to draw the line, right? Anyways, that's going to do it for part 2 of fixing up this Stihl MS440. In the next video, we'll get that oiler off of there, we'll get the case split, we'll get the new bearings, crank seals, you know, break this down and build it back up and put it all back together. Maybe get in some wood. That might be part 4. I don't know how many parts this is going to be, but anyways, thanks for joining me today on Man Time. Get out there, have you some man time too.